So now that we have completed CNN basics, the architecture of CNN, and we have understood how we can solve the very first problem that we can solve using convolution, and that is classification. So now we have understood how we can classify images of what kind of object is in the image. So that we have done. So the next task that we have in computer vision is object detection. So in this segment, what we will be doing is, right, we will be going over two basic object detection terminologies. Then we will be going over some architectures that help us solve object detection. We will be understanding the differences between object detection and classification, and finally we will do some training, some code on object detection itself. Okay, so that is basically the whole thing that we are going to learn in this particular segment of object detection. Fine. Then we also have segmentation. Segmentation itself is of two types, but we are not going to go over all of those right now. Right now, let us just focus on object detection. Okay. So let us understand the differences between classification and object detection. So in classification, what happens is, right, if you give an image, it gives you whether the image is a cat or a dog, or what the object is in the image based on what your image is. But it does not give you where exactly in the image your particular object is, right? So it here will give you whether it's a cat or a dog, right? But if I want to know the exact location of where the cat is, that is when detection comes into position. So here you have a cat. Let's suppose you also had a dog here. In that case, it would have given cat, dog, okay, but it would still not have given the exact position. So this is not a lot of help to me, because I know that object is in the image, but I want to find where exactly the object is. Hence we have object detection. So in object detection, if you will see here, see, you have the image. Now you have more than one object, right? So in that case, what happens is it gives you a boundary box. So this boundary box tells you, okay, this is the place where the object is. So it gives me a blue bounding box. So I can say, okay, for blue it is a dog, for green you have a duck, and for red you have a cat. So that is the whole point of object detection. If you add classification to localization, so localization basically means where exactly is that particular object in the image. So that is localization. So if you localize this, then it becomes object detection, right? So object detection is used, you might have heard a lot about self-driving cars and stuff. So in there object detection is used a lot. Okay, so we have done classification. Now we'll stand up and understand object detection. Both are very useful in their own particular ways. You might be given the task of anything, but yeah, so we have understood classification. With object detection, now we will understand about the boundary boxes and how that can be formed. Okay, but before we go and dive into object detection and understand everything, all the architectures in object detection, we will first try and understand some terms or terminology of object detection, some basic things that have been used a lot. So we will understand that part before we go and understand the deep architectures of object detection models, right? So first let's start with MS COCO. So this is basically a data set. So MS COCO is a data set. This data set is widely used when it comes to detection. That means you use this data most of the time if you have problems like detection. It is also used for segmentation and other things, but let us just keep to detection as of now. So MS COCO basically is Microsoft Common Object Context Dataset. So that is the full form of MS COCO dataset. It has 80 different classes and some 300,000 images. This is a very large data set if you will look into it, and each image can have up to 5 classes. So here if you see, this image has 3 classes. So here it can have up to 5 classes in each image. So this is the whole data set. It is around 37 GB or something. So it is a very big data set. Okay. So this is basically used a lot for object detection tasks. So this is about the COCO dataset, and COCO dataset itself has a few things. We will talk about that later on, but yeah. So this is the whole thing about COCO dataset. Now what we will be understanding is some other terminologies. So we will be understanding something known as MAP. MAP stands for mean average precision. So what mean average precision means is basically, you know precision, right? So precision, if you average the precision and the mean of find the mean of it, it is known as mean average precision. Now it is not that simple as it sounds. So the reason why I am talking about MAP is, see, mean average precision is one of the most important used scores to find object detection. So to solve this problem of object detection, we will use MAP. This is a score that is used. So MAP gives us how well the objects have been identified in a particular image, or how well a model is performing if it is an object detection model. So here, alright, you see this image, you have seen the boundary boxes, right? So here what you are saying is, see, I have seen the image, I have seen the boundary boxes. So I can see and tell, okay, the boundary boxes are perfect. Here you have a cat, here you have a box. Here you have a cat, you have a box. Here you have a duck, you have a box. Here you have a dog, you have a box. Perfect. But we need somehow to score, to measure this out. Hence we will be using MAP. So MAP is basically mean of the average precisions. Okay, we will be talking about this in details. Obviously we will be talking about this now, but yeah, this is what MAP means. And whenever you have object detection tasks, you have to find the value, the MAP value, and higher the value, the better you have the scoring. Okay, so what MAP means is, first let us talk about what is known as precision. You might remember precision, right? Precision was true positive by true positive plus false positive, right? So true positive was basically it is positive and it has been identified as positive. In the same, and false positive was it is identified as positive but it is not positive, it is negative. So this was the whole thing about precision. So what we will be doing is going over this one more time and understanding what this means. So let's suppose this is our query, okay, and this is a set of labeled data. Alright, so you have this particular image and you have this set of labeled data. So what you have to do is basically match this query to the set of labeled data and find out the precision. Okay, so how many true positives are there, false positives are there, and so on. So what you will do is, let's suppose after this whole thing we have found out this list as a list of values, whether it matches or not. So suppose this is matching with this, so I get a tick. This does not match with this, a cross. This does not match with this, another cross, and so on. Okay, so you find out this whole thing, G dash. So once you have this G dash, right, once you have this G dash, right, what you will be doing is finding the average precision. So what precision basically means is, see, I have this G dash. Now what I will do is I'll find the values. So for this value here, I have a true positive and I am comparing it to number of predicted positives. So right now this is the only one that I am using. So this is 1 out of 1. The precision for this number. For this particular precision is 0 out of 2. Here you have again precision as 0 out of 3. Here you have precision of 2 out of 4. Why is this 0 out of 2 by the way? See, here you have one positive, one true positive, right? And you are comparing it to the values. So this is 1. So you get 1 true positive. You have 0 true positive in this position. So 0. And you have compared it to, see, true positive by true positive plus false positive. So at this position you have 1 true positive which was here. And here you have 1 false positive. So 1 plus 1 here, this comes to 2, and number of true positive here is 0. So that is that. Here you have again the same thing, 0 by 3. You have 1 true positive, 2 false positive. So you add this out to 3, and in this position you have no true positive, so hence 0. Now here you have, in this position you have 1 true positive and 1 true positive here. So this is 2 by 4. So in this manner what you do is, like, you basically find out the precision of for all these values. Once you find out the precision, you can divide it by the number of true positives, that is 3 here, and get the overall AP. AP as in average precision. And once you get this average precision, so then what you will be doing is, you will be finding the mean for all the classes. Okay, so I know this is a lot. One by one we'll understand everything and how the whole context makes sense for our object detection here, right? So let me introduce first to IOU. IOU as in intersection over union. So this is what IOU stands for, intersection over union. As the name suggests, suppose you have two objects here, okay? So intersection over union means whatever is the intersection over as in division by the union of the whole thing. So this is basically what IOU means, alright? Area of overlap by area of union, or area of intersection by area of union. This helps to find out, see, this is useful in cases like this. Let's suppose I have a ground truth, okay? So this green one here is my ground truth of the actual, this is what, a ship that is going, right? So I have a ground truth here, and I have TP here, this red one, this is a predicted truth. So what IOU does is, basically it helps us to find how different my predicted value is from the ground value, okay? So I have one boundary box here and one boundary box here. So I will find the IOU of the predicted bounding box with the actual bounding box. If those bounding boxes are very close to each other, that means my object has been detected properly. Hence, what that will mean is, if the localization is properly done, the objects will be, the bounding boxes will be together, and if the bounding boxes are close to each other, I will have a high IOU. So IOU basically tells us, see, you can look and you can say, okay, this is very much overlapping with the ground truth. That means the box is more or less, it can work, okay? We know that, but you have to get a value to actually score this out. Hence, we use IOU. So if IOU is high, that means the predicted boxes are very close to the ground truth boxes, okay? If you will look here, see, here if you see this green one is your true box, right? Let me change the color. So this green one here, this is your true box. Your predicted box is here. So you can see there is not a lot of overlap, right? So in this case, your IOU will be less. In this case, your IOU is high. So this how different the IOU is, helps us in telling, okay, the boundary box that has been predicted is close to the actual bounding box or is very different from the actual bounding box. And we will see how this IOU comes into factor when we talk about mean average precision, okay? We'll come to that one by one. So we will be taking, let's suppose, this example, okay? So this is an image. You have an image here, you have written person, this yellow boundary box represents a person, and here this is a horse, I suppose, okay? So you have this image. So what we will be talking about is how we will use IOU when it comes to mean average precision, right? So what we will do is, we will set a value for threshold. So set a threshold IOU, okay? So let's say my threshold is 0.5. So if any time I get a bounding box, okay, I get a bounding box and that bounding box has an IOU of 0.5 or greater than 0.5. So the overlap between the predicted bounding box, the bounding box we are talking about, and the ground truth, if that is 0.5 or more, so in that case we will classify that IOU as a true positive. Alright, again let me go back. We have IOU. IOU helps to find out how close we are or how much overlap there is of the bounding box with the actual ground truth. Okay, so that we will use to find out whether the thing that has been predicted, the object that has been predicted, the box of that object, is it very close or is it very far away. So that box, then once we get the IOU, we can predict. Okay, we can keep a threshold of IOU, and if the IOU that we get is greater than the threshold, in that case we will predict it as true positive. So now these are some false positives. Okay, here what are the reasons that you can get a false positive? So if your IOU is less than 0.5, so here you can see the overlap, this is the actual person and this is the predicted person box, right? So if my IOU is less than 0.5, in that case I can get a false positive. False positive means it is positive. Okay, it has been predicted as positive, but that is a wrong one. See, it comes here. Now this is very far away from the actual ground truth, right? So I cannot give this as a positive. This is not a person. The person is here. The blue one is the ground truth. So this is labeled as a false positive. The next way that we can give a false positive is when you have duplicated boundary boxes, right? So you have one boundary box here, you have another boundary box here, like the boundary boxes are very close to each other. In that case, it gives you a false positive. And finally, when you have no IOU, obviously this makes sense. If your IOU is less than 0.5, you give it as a false positive, right? That is what we were talking about. So here if you see, it is here, so there is no overlap. So in that case what will happen is it will give you a very less value of IOU, which is actually 0, because there is no overlap. So if there is no intersection, the numerator becomes 0, because numerator is intersection by union, right? So if there is no intersection, in that case this becomes 0 and you have no IOU. So if there is no IOU but it still predicts a like a boundary box, so what that means is it has predicted as positive but it is not positive, false positive. So we will give this a false positive label. Okay, and this here is a false negative. So that means it has predicted, so this is the blue one, this is the original ground truth, and it has predicted no boundary box because you have no yellow boundary box, right? So if there is no boundary box, that means it has predicted as a negative object. So the object is not there, but it is wrong prediction, hence it becomes a false negative. So these are the cases how you will get a false positive and a false negative. So let us go back and understand what is happening. Okay, so we will be doing MAP to basically find out how well our object detection model works. So first what we will do is we will find out the IOUs of the predicted values, predicted truth and the actual truth. Okay, and we will be getting true positive or false positive or false negative or whatever. Now these will be used to find the precision values, right? So these will be used to find the precision, and once that can be done, we'll come back to that later. But yes, so right now what we have done is basically we have used IOU and we have set a threshold. So any value that is greater than the threshold becomes a true positive, any value that is less than the threshold becomes a false positive. So if you have a boundary box where your IOU is very high, in that case the boundary box is a true positive. If you have an IOU boundary box where the IOU is very less, so in that case the boundary box becomes a false positive. Alright, so that is the whole thing, and we also talked about false negative, right? So this is the whole thing, but we will not be requiring false negative so much because we are calculating precision, and precision is basically true positive by true positive plus false positive, right? So this is the whole thing. So what we will be doing is, after you have calculated true positives and false positives, right, once that has been done, what you will do is you will make a table. So suppose in a particular picture I have 3 true positives and 4 false positives, right? So I have calculated in an image, so there was an image, there were 3 true positives. That means it had, let's suppose here also you add one more box. So this was predicted as horse and here you had a tree. So these are 3 true positives here, and you have something like this. This says a tree, but this is not exactly a tree, so you have one false positive here. You have some box here that says man, but there is no man here, so this becomes a false positive, and so on, right? In that manner you have 4 false positives in an image and 3 true positives. Are you getting my point? Okay, so you have false positives and true positives. So the first thing that we will do is, right, we will go over each true positive and false positive. So we will be going over all the boundary boxes. So if it has 3 true positives and 4 false positives, that means it has predicted 7 boundary boxes in an image, alright? So 7 boundary boxes you have. So what you will be doing is, right, you have 7 boundary boxes and you have 3 positives in that and 4 false positives, okay? So you will write that down in the form of a table. Now where will you write true positive and where will you write false positive? Now this is a very tricky thing, and they did not say this a lot, and this got me to thinking a lot. Like when I was reading about the whole thing, right, I had a lot of questions like how do you do that? So along with getting an IOU value, right, a boundary box also gives you a confidence value. So confidence value basically means how confident the boundary box is about that particular object. So here if you have a boundary box, right, and the boundary box gives you an IOU, and that IOU, it says that it is of a man, but it has a low IOU, let's say 0.3 or something, and but at the same time what it is saying me is that the confidence, that it is very confident that here you have a man, okay? So the confidence is very high, like 0.8 or something. You remember how we calculate confidence? Confidence is usually calculated through softmax or something like that, softmax or sigmoid values, because they are used to give probabilities, and these probabilities are basically the confidence level. So for different models this calculation of confidence is going to be different. We'll talk about that, but yes, you can for now say for every particular boundary box you will also get a confidence value. And what you will be doing is, now I have an image and I have all these 7 boundary boxes. So what I'll be doing is, I'll be sorting those boundary boxes in a descending order. So in the top most it will have most confident boundary boxes, and the lowest will have least confident boundary boxes, okay? So I have sorted them out in a descending order so that it gives me now a list of true positives and false positives. You need to understand one thing. See, this IOU that we are calculating, right, the IOU is not at all related to confident, right? So one model, it has been branched into 2 ways, and one branch is to calculate out the IOU, okay? The other branch is to calculate the confidence. So these two are very different, and you might say, okay, if this has a high IOU it can have a high confidence, but those two are not related at all, okay? You have this image, okay, so this image you have, it has it will be passed out into a model that has 2 different branches. So the first branch will calculate the IOU, okay? So the intersection over union it will calculate. The other branch will calculate the confidence. So since these 2 branches of the model are not related in any manner, so there can be no correlation between IOU and confidence, okay? I am saying this right now, okay? So now what you will do is, you have sorted all the boundary boxes in the manner of descending order from most confident to least confident, okay? Once you have sorted those boundary boxes out, okay, so you have boundary box 1, 2, 3, whatever, in that manner, once that has been sorted out, the next thing that you will do is, you will calculate the IOU for that particular boundary box. If let's say my threshold is, let's suppose for this question my threshold is 0.5. So if I get an boundary box and the IOU is above 0.5, it becomes a true positive, else it becomes a false positive, alright? So in that manner, first I sort out from the most confident to the least confident. Once that has been sorted out, I find the IOUs, intersection over unions. Now that I have found out the intersection over unions, I will categorize them into true positive or false positive. Okay, now this column here, this has been done. The next thing that we will do is calculate the precision. So precision, again, how do we calculate? See, this is true positive, this is the first true positive, there is no false positive before that, so we have 1 by 1 which is equal to 1. Then you have one false positive here, right? So in this false positive, what you are having is, see, you have in this, now when you come to the second part, you have two numbers, right? So here you have one false positive and one true positive. So you have, since precision is true positive by true positive plus false positive, you have one, among these two you have one true positive, one false positive. So 1 by 1 plus 1, this is equal to 1 by 2, 0.5. Okay, in the next part that you come here, 3, you have two true positives now and one false positive. So 2 true positives and 2 true positives plus 1 false positive. So you have 2 by 3. Then you come here, you have false positive again. So now you have 2 false positives, 2 true positives. Okay, so you have 2 by 4 which is 0.5. You have here, now in this case what happens is 1, let me change the color. Okay, so you have 1, 2, 3. You have 3 false positives. How many true positives do you have? 1 true positive, 2 true positives. Okay, so you have true positive equal to 2, true positive again is 2, and false positive I've got as 3. So this comes out to be 2 by 5. So in that manner you calculate the precision. Alright, precision has been calculated for all the 7. Now you have to calculate the recall. So the recall is basically the same thing. The recall was true positive by true positive plus false negatives. Okay, so here what you will do is, see, you have one true positive, but how many true positives are there in total? So you have 3 true positives. So this is your first true positive. Total number of true positives are 3, no false negative, so 1 by 3. In the next part you will come here, you have false positive, so there is nothing to do with false positive, so your true positive is still 1, your total true positives is 3 and false negative is 0. So this comes out to be 1 by 3. In the same way, when you come here, you have 2 true positives now. So this becomes 2 by total number of true positives, that is 3. So you have 0.67. In that way, you calculate the recall here. Okay. So you have calculated precision, you have calculated recall. Now we come to something known as precision interpolated. Now this is something different. Okay. So when we talk about precision interpolated, what that means is, for every similar recall you have to find the highest precision. Okay, and you have to write that as the actual precision interpolated. So for every similar recall, so here you have 0.33, here you have 0.33. So these two are similar recalls. So for these two similar recalls, what are my precision? 1 and 0.5. So the highest of these two precisions is 1. So I write 1 here. For the next one, I go here. Again, you have these two recall as the same. So this recall and this recall are same. Out of these two, the highest precision is here 1. So you write 1 again. Now you come here. Now these 3 recalls are similar. So for these 3 recalls, my precision interception is going to be similar, these 3. Okay, so these 3 recalls are similar. In these 3 recalls, what are my precision? 0.67, 0.5 and 0.4. 0.67 is the highest. So my next 3 precision interpolations are 0.67. Okay, so for every similar recall you will have the same precision interpolation. Okay, first of all that. Secondly, for every similar recall you will find the highest precision, and that will be your precision interpolation. Then you come here, these 2 recall are similar, so that means these 2 precision interpolation will be similar. Here, what is the highest among these 2 precision? 0.5 and 0.43. 0.5 is highest, so these 2 I'll have 0.5. So that is how I calculate precision interpolation. Alright, so what we will do is, right now the most used method is basically finding 11 point precision. Okay, so this is basically used to find your average precision. Finally, now see, what you have done as of now is, you have used IOU, you have used confidence value, you have found out true positive, false positive, and you have created this table kind of thing. Now what you will be doing is, you will be finding out the average precision, not the precision like we were calculating. So what you do to find out that is, you divide your recall to 0 to 1. So you have 0, 0.1, 0.2, and this goes on till 1. So you have 11 points here, hence 11 point precision. Alright. So you have your recall here, and you make a table, a graph out of it, and you divide it into formats. So 0, you have 0.1 here, 0.2, 0.3, and so on. Okay, you make a precision versus recall graph, and you divide the recall into 11 points from 0 to 1. So 0, 0.1, 0.2, and so on. Once you have made that out, the next thing you will be doing is you will be plotting these precisions out. Alright, for every recall. So see, for recall you will be plotting these precisions out. Precision interpolation you will be plotting out. So you have recall for 0.33, 0.33, the whole thing is 1. Alright, so everything before 0.33, here the entire thing will be 1. Next, what you will do, 0.67, 0.67, 0.67. For 0.67, your for recall 0.67, your precision is 0.67. So from 0.33, here it was 0.33, right? So from recall 0.33 to 0.67, your precision is 0.67. So in that way, what you are doing is you are plotting out the interpolated precision and you are plotting out the recall. So this is a graph basically between precision, interpolation, and recall, right? So this and this. Okay, this is my precision interpolation that I have plotted out. Once that has been plotted out, what I'll do is basically I'll divide the recall into 11 points, like you remember 0, 0.1, and this goes on to 1.0, right? Once that is done, what I'll do, for every recall in 11 point precision. Okay, so for every recall in this scale. So now that you know this, you have divided your recall into 11 scales, 11 numbers. So for every recall, you will be finding out the precision from the precision versus interpolated precision versus recall graph. Okay, so I know this is a very big step and all these steps are a lot, but just bear with me. Alright, so we are very close. So now for in the scale 0 to 1, the first number is 0. For recall 0, you have precision 1. For recall 0.1, you have precision 1. Because see, till recall 0.33, my precision interpolation is 1. So for recall 0.2, my precision is 1 again. And for 0.3, my precision is 1. Next, what I'll do is, I'll go for 0.4. Now from 0.33 onwards, my precision interpolation is 0.67. So now the next thing I'll be doing is, for 0.4, my precision comes to 0.67. For 0.5, my precision is again 0.67. For 6, my precision is again 0.67. Right? Now for 7 onwards. So from 0.67 onwards, my precision is 1, back to 1. So in that way, what I am doing is basically, right, I am calculating the values. So I am calculating the values for precision for 11 point precision recall scale. Alright, so I have made the recall versus interpolated precision graph, and I have plotted the whole thing out, right? So these are 1 values, recall versus precision interpolation. Okay, I plot the whole thing out. Once I have plotted that out, what I'll do is, I'll divide my recall into 11 points, starting from 0, 0.1, 0.2, so on till 1. Okay, now for all these particular values, I'll be calculating the precision from the graph itself. Once that precision has been calculated, I'll average out all those precisions. So now that you have averaged out all those precisions, that means it will be 1 by 11, because you have 11 such points. So you have 4 ones, so 1 plus 1 plus 1 plus 1 and so on, right? Then you have 0.67 plus, so this goes on for 11 such data points. So this is your average precision. Since you have averaged out all the values, you get the average precision, right? Now this precision was basically for one class. If you have many classes, So you will be finding out average precision for each class. Now for each class, once you have found out, so let's say I get an average precision of, let's say, 0.3 here, 0.5 here, and so on. So I'll find the mean of all these average precisions, and after I have found out the mean, I get the value of MAP, mean average mean average precision. Okay, so I know this is a lot, but let's just go back one more time. We talked about IOU, we talked how we can find IOU, okay, and we also talked about that each bounding box gives us two values. One is an IOU and the other it gives us is a confidence score. So how confident it is that there is that particular object. So I have a bounding box, and the bounding box will give me, okay, I am 100% confidence or I am 60% confidence that a cat is there in that particular bounding box. Okay, if you remember, also in classification we had the whole thing, right? If you remember, in classification also, when you were doing cat versus dog or whatever, we were doing the sigmoid whole thing. So you had this image, right, and you had a cat image, and when your model was asked to classify this, it gave you a value 0 or 1. But if what you can also do is, right, you can also get the value that is known as the confidence value. So this also gives you a confidence value. When we were doing multi-class classification, remember when we were talking about the MNIST data set, and after doing a CNN, it gave me all those values, that it is like 90% positive or 90% confidence that the number is 5, 99% positive that the number is 2, or whatever. You were getting all these values, right? So these values are the same as in the bounding box. So in the bounding box it will say, okay, I am 80% positive this is a cat. Okay, so from those bounding box confidence, you will sort out your true positives and false positives in the particular manner in a descending order. Once you have done that, you will find out your precision, you will find your recall, you will find your precision interpolation. You will graph out recall versus precision interpolation. Once you have graphed out the whole thing, you will define your recall, or you will divide your recall into 11 points, and for each point now you will find out the precision interpolation. Now once that has been done, you will average out all the precisions that you have got, and now averaging of those average precision basically gives you the mean average precision. It's a lot, I know, but yeah, calm down, because you are going to use this a lot. And my final thing is this COCO dataset, MS COCO dataset. It has average precisions, right? So in average, see, the whole thing behind the whole MAP, the main point of this is what do you see or what do you set as an IOU value. Okay, so let's say here in this image, right? So in this image, if I had an IOU of 0.5, IOU threshold of 0.5, and this gave me, so my threshold is 0.5, and from this box I found out the IOU is 0.7. So if this is greater than 0.5, now since this is greater than 0.5, this bounding box will be known as a true positive, right? But think about this, if I had set my IOU threshold as 0.8, in that case it gave me a 0.7. So what will happen in that case? This true positive will become a false positive, and this true positive versus a false positive, they will change this whole table thing here. Once that has been changed, the graph changes, the average values change, and so the map changes, right? Mean average precision. So it is very important to understand what you set as your IOU threshold. So in MS COCO dataset, what they have done is, the map is basically 0.5 to 0.95, and it keeps increasing by 0.05. So what that means is, see, you find the average precision when your IOU threshold is 0.5. In the next time, you find out your average precision when it is 0.55, because it increases by 0.05. The next time you find out your average precision, mean average precision, when your IOU threshold is 0.60. Then your IOU threshold increases to 0.65, and so on. So you will calculate your mean average precisions for all these values, and this goes on till 0.95. And once you reach that, all these values, they are again averaged. Okay, So that is how you calculate mean average precision when you are doing your COCO data set. All right. So this is the whole thing about mean average precision. I know this is a lot, so calm down. Don't have to go through it. I would suggest go back, revise the whole thing again, see the video again if you are having some problems. So that is it. I hope you enjoy this and keep learning.